Hello, I am Ahmad, and in this video we are going to continue the anchorage length calculation. In the previous video, we went through the calculation of anchorage length of T16 from a concrete slab connected to a wall. In this video, we are going to have three different anchorages, which are about the connection of a column towards a foundation. And the footing has some limitations for connection and also the space. It's very practical. Also, the anchorage length of the foundation reinforcement is also covered in this example. Let's do it. A concrete column connected to the foundation. The foundation dimensions are 2 by 3 meters according to the design. And the column is 500 by 500 connected to this footing. And it is reinforced with the 8T25 as shown in the section view. 8 4T25 in each side, so 8T25. And the syrup is T12 every 150 millimeter. The foundation is also reinforced with T20 every 200 millimeter. If you are designing in Finland, instead of @ sign, K is used for the center to center, so T20 K200. And so as we can see, the column is going to be connected to the foundation, but for the architectural matters, the column is not centered through the foundation. The reason might be the collision between the foundation and the neighbors, or you have limited access to the ground. For example, you are hitting the rock and you cannot extend, or you don't want to excavate the rock. So then at some point you might be limited to using a smaller length for one side of the foundation. In that case, then you need to design the reinforcement properly. So in this example, we are going to start to calculate what is the anchorage length of the vertical reinforcement, which you need to extend through the foundation, the red ones as well as the green ones. The difference is that if you calculate the anchorage length with the green one similar to red one, and you bend it towards right, then perhaps you do not have enough anchorage length. As a result, there is an option that you bend them as a loop toward each other, or for example, from this, if we look at them from the top, they come in this direction. Then you have enough space. For the others also, you can bend them either sides with a little bend, and the other one in the other direction. So here you have more space compared to the other direction. But if you come toward the horizontal direction from the plan, you might not have enough space. And here the red ones are going to be bent in this direction. It is easier. And we have enough space in that direction. And also we are going to check what is the required length for the blue reinforcement. So if you are putting the foundation on the ground, then the distribution of the load can be something like that from the ground. Then you need to design proper reinforcement that we can go through to the other example regarding foundation design later, not for now. And then you need to define what is the anchorage length of the reinforcement. If we look at the blue reinforcement from the left side of the concrete column, we have enough space to extend the reinforcement, but for the other side, we need to bend it. Now in this example, we are going to calculate what is the anchorage length of each reinforcement, and then when you calculate, you can sketch the detailing properly. So assumption, concrete class C3545 and Fy of the reinforcement 500 megapascal. What else do we need? T for the red ones is 25, T for the green ones is 25, and for the blue one it is 20. Red and green, and this is for the blue ones. Cover in the foundation is 60 millimeter. Usually the concrete is for the foundation, concrete is with more bigger size of aggregate, 32 millimeter. Then you might need a little bit more cover. Also, the exposure class is changed if we are talking about residential building or offices. So the internal elements are usually with XC1, and they need less cover. But if we compare with the foundation, they are rarely dry. They are most of the time they are wet, and the exposure class will be XC2. As a result, you might need more cover. So now we are going to calculate the LB required, which is phi divided by 4 FYD. Now we can see that we can calculate according to the maximum capacity of the reinforcement divided by FVD. And usually they are in the bottom and they are with a good bond. So we can assume they are with good bond. For C3545 from table 3.1, we can take FCTK 0.05 and it's 2.2 megapascal. Then we can calculate easily FCTD, which is alpha CT times FCTK 0.05 divided by gamma C, and it's 1 times 2.2 megapascal divided by 1.5. 2.2 divided by 1.5, it's 1.47 megapascal. And from there, we can calculate FBD, which is 2.25 eta 1, eta 2 times FCTD. So here we assume that the condition is good, and also eta 2 because the reinforcement diameter is less than 32, so it is 1. So FBD will be 3.3 megapascal. Now we can calculate LB required, which is phi divided by 4 FYD FBD. So it is 25 millimeter divided by 4 times FYD is 435 megapascal divided by 3.3 megapascal. 25 divided by 4, 435, 3.3, it's 824 millimeter. And so this is the required length of anchorage. And if you have enough space and you don't want to calculate any other factors, then you can calculate LBD to be the same as LB required. So LBD will be alpha 1, 2, 3, 4, 5 times LB required, should be greater than LB minimum. And so if you don't want to calculate these values, you can assume that they are 1, and this is 824, and this is the maximum of 30% of LB required, which is already greater than this value. 10 times V, which is 250 and 100 millimeters. So then we can say that LBD can be 824. We round it to the next 50 millimeter, then it will be 850 millimeter. You need to check if you have enough space to do so. So if we come back to here, from one side we have enough space, and if we look at from the top, so the corner one from here, or we can say that from this point to here we have 2000 minus 500, 1500, 750 millimeter. So then we can see that in the other direction, perhaps we do not have enough space because we do not have 850 millimeter. For the red ones, we have enough space. If we calculate this distance, it's 2 meters. And you have enough space to extend the reinforcement. In the other direction, we have 750, but we need to notice that the anchorage length is started from the point of the maximum tension. So when you have the concrete connected to the concrete column connected to the foundation, the maximum tension would happen here. And usually we go a little bit down because of the concrete cover, which is not effective. So perhaps the effective point would be 60 millimeter below this level. So from this point to the place that we can start to bend, let's check what is the space. So here 800 millimeter is the depth of the foundation, 2 times 60 millimeter cover top and bottom. Then we have one reinforcement in the bottom, which is 20 millimeter times 10% bigger margin for the ribs. Then we have also the other side reinforcement. We can assume that they are also 20. So if we calculate this value, it will be 800 minus 120 minus 1.140. So it will be 636 millimeter. So it means that up to this point that you start to bend, you have already 636 millimeters. So we have enough space. You can extend it a little bit bigger, or you can round it to 1 meter even. Then you sketch it in the drawing. So if you want to calculate exactly what is the required length, then you need to multiply by the factors alpha 1 and alpha 2. They are bent. You can check what is the alpha 1, 2, 3, 4, 5. Especially if you have stirrups inside the anchorage length. Here we can see that we have stirrups in anchorage area. So in this case, you can also use alpha 3 to decrease the anchorage length. One important point is that if you design the concrete column to be connected as a hinge to the foundation, then they are not under tension. At least they are not designed for tension. Those which are extended towards the footing. They are called dowels, and dowels are usually designed for only shear force. That is completely another story. We can discuss about it later. But if you design the concrete column or the plinth connected to the foundation for tension, then we need to provide sufficient anchorage length. The last part is the calculation of anchorage length for this blue bar. As I mentioned earlier, we have the soil reaction And we have two critical sections for this case. One is in the face of the concrete in the right side, one in the concrete face in the left side. So here we can assume we have a cantilever, very short cantilever. And as a result, it's under bending moment from the bottom to the top. And as a result, the bottom of the element will be under tension. Here in this example, this, if we assume it's a simple beam with 500 millimeter length and height of 800, it's not following the Bernoulli hypothesis because now it's a deep beam and the design of reinforcement is a little bit different. But from Anchorage length point of view, if you design it for, let's say, T20 every 200 millimeter, then we need to have sufficient anchorage length, which starts from the point of the connection to the or adjacent point along the column face from here. Again, we can calculate easily according to the given equations. So LB required is phi divided by 4, FYD divided by FBD. We are using the same concrete for the foundation. So FBD is 3.3 megapascal. Divided by 4, 435, 3.3 megapascal. 5 times 435 divided by 3.3, it is 660 millimeter approximately. So here we can see that if you don't want to apply any factors like alpha 1, 2, 3, 4, 5, then LB will be also 660 millimeter and it is greater than 10 times B, 30% of LB required and 100 millimeter. So we can see that we have enough space for this bend, but if you wanted to have a straight bar, it could not be straight because you have only 500 millimeter. Let's sketch and explain better. And assume that this is the column face. So here the maximum length that we have, this is 500 millimeter. And we need 60 millimeter cover. So the available length is 440 millimeter. And if you have a straight bar, alpha 1 will be 1. Most likely alpha 2 will be 1. And usually we do not have a stirrup to confine the reinforcement in the bottom unless you weld the transverse reinforcement to them, which is not very practical or at least not very common. So as a result, you cannot provide 660 millimeter here. So we have to bend them upward and then we can provide the required length. Thank you for watching. That was the end of this example. We went through the calculation of anchorage length. We assume that all factors are 1, and but if you are in a way that you want to save material or you want to calculate more accurately or you are doing some research, then you can use other factors to reduce the anchorage length. And later in the other videos, we will go through the lap length and calculation of the overlapping of the reinforcement, which would be practically very important how reinforcement should be overlapped. Thank you for watching. See you next time. Bye.